In this example, we're going to sketch the graph of a function from the list of information that we've been given. So let's go through it piece by piece. So in the first item, I have f of 0 equals f of 2, and that they're both equal to 0. So that's giving me 2 points. 0, 0, and 2, 0. So I can actually put those on the graph. At 0, there's an x-intercept. At 2, there's an x-intercept. Okay, then it tells me that f prime of x is greater than 0, positive, if x is less than 1. So f prime positive until x equals 1. So something's happening at 1. And in the next piece of information, it shows us 1 is a critical number because f prime of 1 equals 0. That means x equals 1 is a critical number. We don't know whether it's a max or a min, but we'll look at the next piece of information that will help. F prime of x is less than 0 if x is greater than 1. So now they're showing you the change in your slope. So f prime of x negative after x equals 1. So let's put this in interval notation below. I know from negative infinity to 1, f of x is positive. And then from 1 until infinity, f of x is negative. So looking at what that tells us, we know the slope is increasing and then decreasing. So that makes 1 a relative max. So this tells us that x equals 1 is a relative maximum. Now, final piece of information. F double prime of x is less than 0, meaning negative. So if f double prime is negative, then f is concave down. Now, let's look at what they didn't give us. They didn't say f double prime is less than 0 between negative 2 and positive 10, or any other type of restriction. Therefore, we can conclude that this is concave down everywhere because we don't have any other restrictions. Okay, so now we're ready to sketch. Now, it makes a difference how steep I draw my graph. For example, if I'm in the negative values, because I know I have to have a positive slope to reach 0. So when x is negative, y is negative. So if I start way over here and I say I want a really tall vertex at 1, that my maximum is going to be way up there. Watch what has to happen in order to reach that point. Look at my concavity in order to reach that point. That is concave up. And so that's a problem because that's in a conflict with the information I know. So I'm going to erase this and we're going to try again. Okay, so another option is that we're still, when x is negative, y is negative. But if I start too close to the y-axis and I say I want a short vertex, see how that flattens out? That kind of follows my negative down concavity, but it doesn't look right. And so you have to understand is that your sketch isn't going to be perfect, but you want to make it as close as possible. So I'm going to do one final one and make it better. Okay, so I know my vertex is at 1. I don't want my concavity to change. I want to make just an average graph. So I'm going to put my vertex right about there. And again, remember, I'm estimating because I know my vertex is at 1, and I would need the actual function to say when x is 1, what is y? So remember, this is an estimate. I'm just trying to get a good sketch that matches all of the information that I have. And so that follows everything that I was given. I have a positive slope until x is 1. I have a negative slope after x is 1, and it's concave down everywhere. So you're just trying to get it as close as you can.